2.6 Absolute value equations and inequalities. With these absolute value equations, we want to first isolate the absolute value bars, and then from there, give ourselves two equations. You want to think about your answer with all of these, specifically because the absolute value of any number is always a positive number. You cannot have the absolute value of anything equal to a negative number. So when you do, it would be no solution. So our first thing that we want to do is to make sure the absolute value is isolated. If we look at example 1a, we have the absolute value of x minus 7 is equal to 2. That absolute value is isolated, so from here, set up two equations. One with the answer that you already have, one with the opposite of the answer that you have. So this is going to give you x minus 7 is equal to negative 2, as well as x minus 7 is equal to positive 2. We add the 7 to both sides. We get x is equal to 5, as well as x is equal to 9. So we just write this in braces as 5, 9, close braces, and then we're done. For b, we have the absolute value of 3x minus 5 is equal to 7. We have our absolute value equal to a positive number, so we're going to separate this into two equations. So we're going to get rid of those absolute value bars, have 3x minus 5 is equal to the opposite of 7, so negative 7, as well as 3x minus 5 is equal to the 7. We're going to add the 5 to both sides. We get 3x is equal to negative 2, as well as 3x is equal to 12. Then we just divide each side by the 3. And we get that x is equal to negative 2/3, as well as x is equal to 4. So this is just 2/3, negative 2/3, comma 4 in our braces. For example 2, we're solving the absolute value of 2 times x minus 6 plus 7 is equal to 0. Since this one's equal to 0, we don't have to have an opposite of 0 because 0 doesn't have an opposite. So we're just going to get rid of those absolute values bars and have 2 times x minus 6 plus 7 is equal to 0. I'm going to distribute the 2 in to give me 2x minus 12 plus 7 is equal to 0. I'm going to combine my like terms to where I have 2x minus 5 is equal to 0. I add the 5 to both sides. I get 2x is equal to 5. And then I divide by 2 to give myself x is equal to 5 over 2. In example 3, we have the absolute value of x minus 9 is equal to negative 6. You cannot have the absolute value equal to a negative number. It is not possible, so this one is no solution. For b, we have the negative 5 times the absolute value of 3x minus 7 plus 4 is equal to 14. So we're going to start this one by subtracting that 4 from each side. We get the negative 5 times the absolute value of 3x minus 7 is equal to 10. Then we just divide each side by the negative 5. And we get that the absolute value of 3x minus 7 is equal to negative 2. Ask yourself, is it possible for the absolute value of something to equal a negative 2? No, so this one's no solution. For example 4, we have the absolute value of 2x minus 1 is equal to the absolute value of x plus 3. So there's no way to isolate the absolute value here, so we are going to take the answer that we have as well as the opposite of the answer that we have. So this just means we're going to do 2x minus 1 is equal to the opposite of x plus 3, as well as 2x minus 1 is equal to just the x plus 3. We distribute that negative in the first one and get 2x minus 1 is equal to negative x minus 3. We add the x to both sides and get 3x minus 1 is equal to negative 3. We add the 1 to both sides. We get negative 2 is equal to 3x. Then we just divide each side by the 3 to get that x is equal to negative 2/3. For the other equation, we just are going to move the x over by subtracting it from each side. So we have x minus 1 is equal to 3. We add the 1 to both sides and get that x is equal to 4. So our two solutions here are negative 2/3 as well as 4. Our next part deals with solving inequalities with these absolute values. When we separate our inequalities, we want to remember that we're switching the sign on our answer, which means our inequality sign also switches. We also want to say to ourselves, as soon as we isolate the absolute value, is it possible for the absolute value of that number, or of the absolute value of any number, to be whatever your sign, your inequality sign says, and the number that's your answer. So for 5, we have the absolute value of x minus 9 is less than 2. So for this one, our absolute value is already isolated. So we're going to have x minus 9 is greater than negative 2 since we changed the sign, as well as x minus 9 is less than 2. The reason why I went on with this one is because it is possible for the absolute value of a number to be less than 2. So that's why it's okay that I move on. From here, I'm just going to add the 9 to both sides. I get x is greater than 7. I add the 9 to both sides on this one. And x is less than 11. I look at these two. I'm going to have an and statement because my two signs go in towards each other. So when I go to graph this, I'm going to find that 7, I'm going to find the 11. I have open circles on both, and my line is going to connect each other with those two circles. To put this in interval notation, I have open circles on both the 7 and the 11, so those are getting parentheses, and the line goes in between the two circles, so it's just parentheses 7, 11, close parentheses. For 6, we have the absolute value of 3x plus 5 is greater than 2. So I ask myself, is it possible for the absolute value of something to be greater than 2? Yes. So I'm going to separate this into two inequalities. I have 3x minus 5 is less than negative 2 because I changed the sign on that 2, as well as 3x plus 5, this should be a plus 5, is greater than positive 2. I'm going to solve both of these by subtracting 5 from each side first. So I have 3x is less than negative 7, as well as 3x is greater than negative 3. I divide each side by that 3, and I give myself x is less than negative 7 over 3, which is the same thing as x is less than negative 2 1/3, as well as x is greater than negative 1. This is an or statement since my smaller number occurs on my left and my signs point out away from each other. So when I go to graph this, I'm going to look for the negative 1, put an open circle on that. My line goes away from that, so to the right. And then that negative 2 1/3 is going to be about here. My line goes to the left. So now that I have my lines graphed, I'm going to have a negative infinity, comma, negative 7/3, parentheses, with a union, since this is an or statement, parentheses, negative 1, comma, positive infinity. For my next example, I have the absolute value of 5 minus 3x is less than or equal to 6. So I ask myself, is it possible for the absolute value to be less than or equal to 6? Yes, so I can continue. I'm going to have 5 minus 3x is greater than or equal to negative 6, as well as 5 minus 3x is less than or equal to positive 6. I'm going to subtract the 5 from each side. I have negative 3x is greater than or equal to negative 11, as well as negative 3x is greater than or is less than or equal to 1. From here, I'm going to divide each side by that negative 3. Remember, I'm dividing by a negative, so I switch my sign. These cancel out, so x is less than or equal to 11/3, as well as x is greater than or equal to negative 1/3. I'm going to switch the order of these so that way the inequality with the smaller number comes first on the left. So I'm going to have x is greater than or equal to negative 1/3, as well as x is less than or equal to 11/3. That 11/3 is the same thing as 3 2/3, so I want to keep that in mind when I'm graphing this. My two signs point in towards each other, so this is an and statement, so they're going to connect. On my number line, I'm going to have negative 1, 0, 1, 2, 3. I'm going to have a closed circle on negative 1/3, which is going to be about here. And I'm going to have a closed circle on 11/3, which is 3 1/3. So I'm going to actually erase this 3 2/3 and keep it going. 3 2/3 is about here, and then my line goes in between the two. So in my interval notation, I'm going to include the negative 1/3. I'm going to include the 11/3. My line goes in between the two circles, so I just have a bracket, negative 1/3, comma 11/3, close bracket. For example 8, we have 3 plus the absolute value of 7 minus 2x is greater than or equal to 3. So then we are going to just subtract the 3 from each side. We have the absolute value of 7 minus 2x is greater than or equal to 0. This is a possibility, so we are going to separate this or rewrite it to where there's no absolute value bars. So it's just 7 minus 2x is greater than or equal to 0. We move the 7 over by subtracting it from each side. We get negative 2x is greater than or equal to negative 7. We divide each side by that negative 2. We switch the sign. We get x is less than or equal to 7/2. If x is less than or equal to 7/2 on our number line, we find that 7/2, which is the same thing as 3 1/2. So this would be 3, this would be 4. We're going to have a closed circle on that 3 1/2, and our line goes to the left, since our sign points to the left when our inequality has the variable that comes first. As interval notation, we're just going to go to negative infinity with a parentheses, and then 7/2 with a bracket on it. For example 9, we have the absolute value of 5x minus 12 is less than negative 2. Ask yourself if this is possible. The absolute value of any number is a positive number. Is it possible for a positive number to be less than negative 2? No, it's not, so this is no solution.